Okay, this is Monday, rainy Monday, April 15th. We have a test tomorrow, April 16th. These are 4 questions that in some variation you will definitely see on your summative test tomorrow. So make sure you understand how to do these, and you will have a great chance of being successful on your test tomorrow. So the first question gives you 2 triangles, and this says here, if I asked you on the test, what does that say? You would say, actually, it should say this one. Triangle ABC is similar to DEF, and that means that the corresponding angles are the same measure, and more importantly, corresponding sides are proportional in measure, which means they will all be increased or decreased by a certain scale factor or multiplied by a certain number. So before we started this, and I didn't have the A and D in here, I put that after some people were confused. So on your test, you're not going to have the A and the D. So when you're asked to find this number here, so I'll use my highlighter, X and Y, we are going to assume that that triangle is the diagram I made for my actual. So before I start, I'm going to put, this was the actual triangle I started with. And this is going to be the diagram I created from that actual. So I define my D and I define my A, which is going to help me immensely when I set it up using either scale factor or proportional reasoning. So if this is true, then scale is defined as being the diagram divided by the actual, or D over A. And that's important to write down first, because then I know that when I set up my proportion, I want my top number to represent the value that came from my D, and I want the bottom number to represent the number that came from my A. So we're going to solve for X first. So the D that I know, the one side in my D that I know is 2.4. So therefore, I'm going to put it in the top part of my proportion, the D. Now the corresponding side to 2.4, it's going to be my bottom number. So 2.4 over 4 is the first ratio of sides I'm going to put down. And then I'm going to put an equal sign, which is read as is proportional to. And I could choose to solve either X or Y. Now I'm going to choose X first, so this one here. X is going to be my D side, and the corresponding side to that X is going to be 10. So when I set it up, I've now created a grade 8 question of proportional reasoning that 2.4 over 4 is equal to X over 10. Now there's 3 different ways you can solve it. Obviously the first way is I can multiply both sides by 2.5, and whatever 2.4 times 2.5 is will be the value of X, because I would solve that using like the idea of equivalent fractions. What number times 4 is 10, and that's 2.5, and that will work. But for the most part, we're not going to use that method because it's not the most efficient. So the most efficient way to solve a proportion is to simply create an algebraic equation, because regardless of what you multiply the bottom number by, you don't have to do any thinking. You just have to make an algebraic equation. And for this equation, we're going to have 4x is equal to 24, because I multiply this way to get 4x, I multiply this way to get 24. Divide both sides by your coefficient, and the value of x, oh, that's not right, can't do division, will be 6, because 24 divided by 4 is 6. So therefore x equals 6, and I can physically erase that, and I can now put the value for x. That length is going to be 6. And the same procedure can happen for the y. I'm just put d over a. And one student said, well, can I use my new one? Because I now know this is 6 over 10. So you could go 6 over 10. That's fine to do. You could also use 2.4 over 4. That will work as well. Equals, my missing d is y, over its corresponding side length, which is 18. So regardless of which one you use, I'm going to use this one here. So here we have, I'm going to use the 6 over 10. You could use the 2.4 over 4 like we did up here if you want to. We're going to use the new one, 6 over 10. So when I multiply here again, I'm going to get 10y equals 6 times 8 is 60 and 48, which is 108. Divide both sides by my coefficient. I'm going to get y equals 10.8. So I can erase my y, and I can put y is 10.8. Now that's solving using proportional reasoning. Okay? And if it doesn't say how to solve it, obviously, if it was me, that would be my default way of solving the question. But there is a different way. And that second way is to determine what did I multiply all of these sides by to create the similar triangle. Or another way to say that is, what was the scale factor? What was the scale factor? What number was it that I multiplied all three sides by to get? And in order to determine that, I would take my D divided by my A, and that is the formula for determining scale factor. Okay? So again, this is going to be my actual, and this is going to be my diagram, because I know all three sides of my ABC, and I don't know my three sides there. So take the side that I know, which is 2.4. It's the only side of my D that I know. And divide it by the corresponding side to it, which is here. And 2.4 divided by 4, you grab your calculator. 2.4 divided by 4 is 0.6. So therefore, the scale factor was that I multiplied all of these sides by 0.6 to create the reduction. And we know that if you multiply a side length by a number less than 1, you create a reduction. If you multiply a side length by something greater than 1, you create an enlargement. And if you multiply a side length by 1, you create a duplicate, right? An exact measurable thing. So then I would take 10 times 0.6 would make this 6, and 18 times 0.6 would make this 10 point, I can't remember the number, 8. And I could solve it that way without having to do too much thought at all, right? Determine the scale factor and then multiply all your sides. That's an easy way to do it too, and it's probably an easier way for most part. But either way you do it, either by proportional reasoning or scale factor, allows you to find missing values in a third or a second triangle. Your second question has a beautiful picture of this 2-meter man was drawn using a scale of 1 to 2.8. What is the scale factor? And what is the height of the actual drawing? So the question is, what is this height here? This was 2 meters here. What is the scale for it? 1 to 2.8. So we know that D over A is your scale. So therefore 1 to 2.8 would be how I would rewrite this, because this is your D and this is your A in your scale, is equal to, using proportional reasoning, the actual was 2. So I'm going to put the 2 down there, and I don't know the diagram's height. So setting it up this way, I could cross multiply. 2.8x equals 2. Divide both sides by your coefficient. And whatever 2 divided by 2.8 is going to be the height of your drawing. So 2 divided by 2.8 equals, the drawing is approximately 0.714 meters, or approximately 71.4 centimeters tall. If you do a quick conversion, since there's 100 centimeters in a meter, divide by 100 to get how many centimeters, and you get 71.4 meters. Now the other way to do it, it says the other question to that is, what is the scale factor? So D divided by A would be 1 divided by 2.8, and the scale factor is going to be an approximation because it's going to be a repeating decimal, but 1 divided by 2.8 equals, the scale factor was approximately 0.3, oh, I forgot already. What was it? 387? 357? I forget. Let's look here again. 1 divided by 2.8, 357. Approximately 357. So the scale factor was taking the original height and multiplying by 0.357 approximately to create the reduction. Now that's important because not only, if I was actually making a picture of something, not only would I use that for the height of my figure, but I would also use it for his arm length. I would also use it for his head size, his leg length, his foot size, so that when I make this drawing, everything is done proportionally to his actual height. The next question. When given two triangles that are obviously similar, and we know they're similar because they both have 90-degree angles, and they both share this angle here. So if two triangles share the same measure of 3 angles, we know they're going to be similar. So the first thing I'm going to do is redraw the big one and the small one. And I'm going to put in the small one a 4 here, and a 10 here. And in the big one, I'm going to put a 12 here and an x here. And it's 12 because if I look at that, it's going to be 12 meters, not 2, right? Once I have that, I can either use scale factor or I can use proportional reasoning. This is the one I know all the sides. That's my A. This is the one I don't know a side, so I'm going to put a D there. D over A will be x over 4 is proportional to, so x over 4 is proportional to 12 over 10. I'm going to get 10x equals 48. Divide both sides by that to get x equals 4.8. So x is 4.8. And in the final question, we have two pentagonal shapes, or two five-sided figures. They're not really pentagons; they're five-sided polygons. I'm going to redraw them using my awesome drawing skills, like that. I'm going to put a 12 here and a 4 here. I'm going to put a 5 here, and I'm just going to call it y right now. Just for the time being, I'm going to call it y, not x, because x is only part of it, right? It's not actually that. I can also call it, if I wanted to, in fact, we will call it that. We'll call it x plus 5. We'll do it this way instead. Either way you can do it, it's fine. We're going to call it x plus 5. So I know both of these. This is my actual. This is my diagram. I'm going to set up with d over a to start. And d over a would mean that 12 over 4 is equal to x plus 5 over 5. So once you set it up as a proportion, you multiply across your proportion. So 4 times x plus 5 will be 4x plus 20. And for those people that don't realize why it's plus 20, I have to use distributive property to expand that. It's equal to 60. Once I have that, I'm going to subtract 20 from both sides to get 4x equals 40. And x will finally equal 10. And if x equals 10, then that's our missing side right here. X equals 10. Or this whole side here, another way to say that, the whole side, since x is 10, would be 15. Now the other way to do it is to determine your scale factor. So again, this is my actual and this is my diagram. So d divided by a will be my scale factor. This number which I know and this number which I know will be 12 over 4, which means the scale factor is 12 divided by 4, which is 3. That means I multiplied this by 3 to get this, and that means this by 3 to get this. So since this is 15, then x plus 5 must be 15. And if I subtract 5 from both sides using algebra, x must have been 10. So you can use it using scale factor to determine that the missing value must be 3.